It's our final lesson of Unit 1, complex numbers. Our learning goal, use the imaginary number set and complex numbers to solve equations and simplify expressions you previously could not, going back to grade 10 and grade 11. So we're going to start with a quick warm-up activity. Solve each. Solving a quadratic means finding the zeros. First one's already factored for us, so it's pretty easy. What makes our first bracket 0? X equals -4 and x equals 2. Easy. B, it's not factored. This one's actually pretty easy. Just bring, well, at least the steps are. Bring that over. X squared equals -4. How do you get rid of a squared? Well, you square root both sides. And don't forget, when you square a root, it's always plus or minus. And if you type that in your calculator, you get an error. And so far, you've been told there are no solutions, not possible. That's partially true. There's no solutions in the real number set. So if you take the square root or any even root, so square root, the 4th root, 6th, 8th, and so on, of a negative number, it's not possible in the real number system. So that means we have to use the imaginary number system, which has the two following key properties that we're going to use. So I squared equals -1, and following that, I equals the root of -1. And just so you know, a capital I is the imaginary number set. We're going to focus on these two things. These are the two properties you want to keep in your back pocket. So we're going to simplify. We're going to solve these. And again, if we look at A and B and part of C, you can't just use your calculator and type in root -9, it spits back an error. But what we can do, we can pull out some knowledge from grade 11 in simplifying radicals. And I can write that as root 9 times root -1, because in grade 11 you learned that when you multiply radicals, you can just multiply what's underneath the root sign, 9 times -1, which still gives you -9. Based off of our new knowledge, this is possible. Root of 9 is 3. We just learned, or wrote down, the root of -1 is I, and 3 times I gives you 3i. Same idea for the next one. We can write this as root 25 times the root of -1. We'll skip out that middle step. That's just going to become 5i. C, square root of 4, 2 plus. And then hopefully you have the pattern down by now. I'm going to skip the steps we just did. If you're not comfortable skipping those steps, write them out. But root of 49, -49 is going to be 7i. And that is your final answer. So I'm going to make a little note here. Do not write 9i. That would be bad. You kind of want to treat I like it's a variable, like an x, even though it's not. And you wouldn't do 2 plus 7x equals 9x. So it's kind of like combining like terms if you want to think of it that way. Building off that idea, collecting like terms, 4 plus 2 is 6. And 3i minus 7i would give you -4i. So that brings us to complex numbers. So 3i, I times root 5, negative 12i are all considered pure imaginary numbers because they only consist of imaginary numbers. When you add real numbers to pure imaginary numbers, the result is a complex number. And complex numbers have the form a plus bi, where a is the real part and bi is the imaginary part. So, for example, 2 plus 7i, we just had that. That's a complex number. Now, you can encounter complex numbers when you use the quadratic formula. So we're going to use the quadratic formula. Hopefully everyone remembers what it is. If not, I'm going to rewrite it here for you. Negative b plus or minus b squared minus 4ac all over 2a. If you're now asking yourself what's a, b, and c, a, b, and c. And again, this should be a review for most of you, so I'm going to skip a lot of steps here. Now, b is negative 2, and negative times a negative makes it positive, so that's 2 plus or minus. I'll let you sub all the numbers in, but when you sub in all the numbers for b squared minus 4ac, you should get negative 16, and then all over 2. In grade 10 and 11, when you get to that part, you're told there are no zeros, which is true. There's no zeros in the real number set. But we now know how to keep going with this. So we can split this off into two solutions. 2 plus, now the root of negative 16 would be 4i over 2, and x equals 2 minus 4i over 2. And these can be simplified further, because they're both divisible by 2. So 2 divided by 2 is 1, 4i divided by 2 is 2i. Same idea here, 1 minus 2i. So we've come up with complex solutions to an equation that has only real numbers in it. Expanding on this, if I asked you to write that in factored form, because remember quadratic gives you the zeros, which goes with factored form, it would be x minus your zeros, 1 plus 2i, and x minus 1 minus 2i. Looks weird. We're going to revisit that in the very near future. This next example is just scale building. State the complex conjugate. Conjugate just means opposite, essentially. And when you do this, the real part is left unchanged, and the sign of the complex part is changed to the opposite. So the complex conjugate, real part stays the same, the imaginary part flips signs. So minus 4i. This would be 3 plus 2i. There is no real part to this, it's just going to be positive 6i, and that only has a real part, so just 17. Now where we're going with this, so you know, I'm going to give you another example. Let's do, we'll do x minus 3 and x plus 3. If you were to FOIL that, we'll do it really quick. X squared plus 3, x minus 3, x minus 9. What you notice is that these middle terms, they cancel each other out. 3 minus 3 is 0. Remember, that's a difference of squares. And the only difference there, the x's stayed the same, but the numbers, they were opposite of each other. And we were able to eliminate one of the terms. So we're going to build off of that. That's kind of where we're going with this. Our next example, expand and simplify. So you can think of this as FOIL. 2 times 4 is 8. 2 times 5i is 10i. Negative 12i. And then negative 15. And I times I is I squared. collecting like terms, if you want to think of it like that. That's going to give us negative 2i. And we can actually keep going with this because I squared, we learned, is negative 1. Let's get the little star there, don't forget. I squared is negative 1. So 8 minus 2i, and that becomes plus 15, which is 23 minus 2i. B. Again, FOIL. 25 minus 10i plus 10i minus 4i squared. Now this is kind of like our complex conjugate part. When you multiply those middle terms, they cancel. Negative 10i plus 10i is 0. So it leaves us with 25 minus 4. I squared is negative 1. 25 plus 4, 29. So that's pretty cool. You actually had something that was complex numbers, and when you multiplied them, you ended up with a single real number, no imaginary numbers whatsoever. Our last example. This looks intimidating. I like this question. So you might want to make sure you know how to do this. So this is like going back to our factored form with complex numbers. All right, so organization is going to be key on this. So first times first. That's easy. X squared. First times last. Well, the last thing is actually, this whole thing is all one term. So really, it's x times negative, and then 3 minus 2i. Inside, well, it's the same idea. This is all one term, so it's really negative x times 3 plus 2i. And then last, so you have a negative times a negative, which is going to make a positive, and then 3 plus 2i, 3 minus 2i. Now that's the hard part. After that, it's not too bad. Now you're going to distribute, so negative 3x. Now this is weird, plus 2xi. Bear with me, we'll take care of it. Minus 3x minus 2xi plus. And here we have another complex conjugate, which we just learned. You could go through all the FOIL steps, but the middle terms are going to cancel. We're actually left with 9 and then minus 4i squared. Now here's something happens that's nice for us, convenient for us. We have a plus 2xi and a minus 2xi, so those weird xi terms are gone. So we have x squared, and then minus 3x is minus 6x. Now don't forget, I squared is negative 1. X squared minus 6x, negative 4 times negative 1. Positive 4 plus 9, 13. So we took factored form with complex conjugates and imaginary numbers in it, and we ended up with something that had all real numbers, a quadratic. So there definitely is a relationship that exists between real numbers and imaginary numbers. But you'll learn about that perhaps if you take any calculus or like senior level, like third year, fourth year level calculus or algebra classes in university. That's as far as we're going to touch on imaginary numbers. So that's it. That's all of Unit 1. If you're watching this, so far you've survived. All that I have for you for work is a handout, which is posted on D2L. There's your review questions. And then There's one more video that's coming that's just me kind of going over the expectations of the test with you. Please make sure you watch that before you go to write the test, preferably like Friday morning or Thursday night, just so if you have any questions, you can ask me. And then, of course, you have your test on Friday afternoon, and then 1 unit down and 6 more to go.